Okay, so this is going to be an example again of a sigma unknown scenario. Okay, and again, this is going to be where we assume that the standard deviations of our population are indeed equal. So I'm going to be looking at number 7. You've got your basic no alternate. This is a two-tell test. They give you a couple different samples. And so obviously, I've got to plug in. I'm going to go ahead and draw my curve like I always do. And so you're going to have an upper and it goes, of course, a lower tell test, two-tell test. And so if you look at the data, we've got, I'm going to kind of put this out over here. So you've got sample size 1. It's a random sample of 10. Okay. They give you X bar 1 equal to 23 and a sample standard deviation equal to 4. So I'm just going to label this just to kind of bring it out of the problem. And then it says there's another sample. I'm going to label that as N2. That's going to be a sample size of 8. And as I keep reading, it says that the sample mean from there was 25. So that'll be X bar 2 is equal to 25. And the sample standard deviation of 2 is equal to 5. So you notice that based on the sample data, that the sample standard deviations are very similar. So therefore, we can also assume that the population standard deviations must also be similar. Now, the alpha level here is going to be 0.05. So two-tell test, we divide it in half. So alpha half is 0.025. Okay. And remember, our degree of freedom is going to be N1 plus N2 minus 2. So obviously 10 plus 18, 8 is 18 minus 2. So your degrees of freedom is going to be 16 in this particular example. And so to get your test stat, obviously you have to plug into that crazy formula. But remember, you got to do that pooled number first. So I'm going to run out of space here before I do anything else. So to get that pooled number, I'm just going to take the numbers and plug it into the equation. You can go back and reference the equation. So the pooled number is going to be in the numerator. It's sample size, the first one, 10 minus 1, n minus 1, multiplied by that 4 squared. Okay, so that'd be that part. Plus the second sample, 8 minus 1, multiply that by 5 squared because that's that sample standard deviation. And then you divide this by your degrees of freedom number. So it's 10 plus 8 minus 2. And at the end of the day, I'm going to round this off to 2 decimals. You're going to get about 19.94. Now, once you get this number, that's the number you're going to use with your test stat. I'm going to kind of write that way up here. Hopefully there's enough room I can plug it in here. So to get your test stat, it's going to be your sample size, your 23 minus 25. That's from your 2 samples, all over the square root of 19.94. That's the number we just calculated, multiplied by 1 over 10 plus 1 over 8. And again, all that's under square root. And I'm going to take this out 2 decimals. That's about a negative 1.42. Okay, so hopefully you can kind of follow that. And then of course, you've got to be able to look up a test stat. And so using degrees of freedom and a two-tell test, this is again alpha half, two-tell test at 0.05, you should get your test stat rejection number at 2.12 and a negative 2.12. And obviously negative 1.42 is going to fall somewhere there. So you're going to say, again, do not reject the null. So again, I hope this one helps.